Hi, my name is Brian with Ace Appliance in Toledo, Ohio, and welcome back to another quality video from ApplianceVideo.com. It seems to the microwave, nothing's lighting up, just a dead microwave at this point. Alright, so the first thing we want to do is make sure we have proper voltage at our outlet to the microwave. So we're going to test between neutral and hot or common and make sure we have 120 volts, and then which we do, and then from hot to ground we should have 120 volts, and from neutral to ground we should have no voltage at all, which we do. So our outlet, we have the correct power there. Alright, so the first thing we're going to do is gain access to the fuse to check the fuse, since we have proper power to the microwave and the microwave's not lighting up or has no power, it seems like. So we have one screw on the top here, and then we're going to have 3 screws here. They're all Phillips screws to take this vent trim piece off, to be able to take this control panel off to gain access inside. So we'll take the top one out. 3. And now our trim piece will pull straight off, up and off. Alright, next we'll open up the door here, and we're going to be taking the top Phillips screw out here of the control panel so we can take it off and gain access to the inside. It's a Phillips screw. Take that off of there, and then the control panel should lift up and come out to about there. Okay, well, after taking the panel off and locating where the fuse is, we're actually going to have to bring the microwave down, unmount it from the cabinets to gain access to the fuse. So we're going to put the control panel back on right now, put the screw back in. For the time being, and move on to the uninstallation. To further diagnose this microwave, we're going to need to pull the microwave down, uninstall it from the cabinet here. So the first thing we want to do is to protect the stove. We're going to put our appliance moving blanket down on top of the stove here, so that we don't scratch or damage anything when we bring the microwave down. To remove the microwave here, what we have on this particular one, there's going to be 2 5/16 bolts that hold it through the cabinet that the microwave kind of hangs on. So we're going to remove those, and then on this one also we have these 2 long carriage bolts that go through the front here and attached to the bracket that's attached to the back wall. These ones here are going to be, they are 3/8. So we're going to remove those and bring the microwave down. The back of the microwave hangs or sits on a bracket that's mounted to the wall in the back there. So we'll go ahead and remove our 2 3/8 bolts that hold it through the cabinet, and you want to be careful to kind of help support the front of the microwave up when you remove it, because it is going to come down. And then next we'll remove our 3/8 bolt here from the front. And at this point, it's going to come down. You also have your vent up here. The vent should just kind of slide out as you bring it down. You might have to adjust it a little bit, help it come out of there as you bring the microwave down. And the microwave, now you can bring the front of it down. You're going to push up and lift the microwave out of the bracket in the back. This is a lot easier if you have 2 people to help support it and bring it down, but one person can do it if need be. Alright, now that we got the microwave down and spun around to the back side of the microwave, we need to gain access inside of the microwave. First thing we're going to do is check our inline fuse. So to do that, we need to take the cabinet off, or the outside trim piece here, and to do that we have some screws, some Phillips screws along the back edge here. So we're going to remove those. Now we're just going to lift, we got the screws out of the back here. On this particular one, there was no screws on the tops or along the bottom edge here like there is on different models that we had to take out. So just the screws on the back, and then this whole outer cabinet here will lift up and off of the unit. You have to tip it about like this to remove, there's a tab in the front side here where it attaches to the cabinet. It just kind of pulls out of there. So we can lift this up and off. On this one, what we're going to have is our power cord still is attached here through the cabinet. So we're going to reach in, and there's just a wire harness that we're going to grab and pull off to bring the power cord, to unattach the power cord also, so we can lift this whole unit up and off. Alright, so here's the harness for the power cord, so we can remove the power cord and take the whole cabinet off. It's just got a tab. We're going to use our screwdriver here to get in between here on the tab to push it in, and then it's just going to lift up and straight out. Alright, so once we get the outer cabinet off the microwave here, one thing you always want to do with microwaves is discharge the capacitor. The capacitor holds, roughly 2,000 volts, and to not get electrocuted, we want to discharge it, because capacitors always hold a charge even without power hooked up to it. So first thing we're going to do is take some insulated needle nose pliers, and we're going to pull the wires off of our capacitor so we can get access to the terminals of it to be able to discharge it. Now that we got our wires off and out of the way, you're going to take two, you can take two insulated screwdrivers, and you're going to go from one side of the capacitor to the other side, and then touch your screwdrivers together. And that there is going to discharge the capacitor of any voltage that it might be storing. Alright, so the first thing you want to check is going to be our inline fuse, located right here. To check that, just a resistance continuity check. We need to disconnect the fuse from at least one side of the line. So if we just go like that, we can then test it. I'm just going to do an audible test with the fuse, and we should be hearing the audible tone. The fuse is blown on this one. Alright, so the fuse is blown, and it's usually caused from another part malfunctioning or being bad. You can use a tester to clamp onto each side of the fuse so you don't continue to put fuses in and blow the fuses trying to test it out to find out what exactly is going wrong with it. Today I don't have my tester with me, so we're going to use a fuse. So basically you're just going to remove the old fuse and install your new fuse, like so. Alright, so we got our new fuse in there, and we spun it around. We're going to just temporarily get our cover back on for the purpose of being able to plug our power wire back in to test it out. And you want your cover back on while it's running. You don't want to accidentally touch anything inside while it has power for safety issues. We did reattach the wires to our capacitor before we did this so that we can test out the microwave. So we got that back on there. We're going to plug it back in with our new fuse and run it and see what happens. Got power back to the, well, we replaced the fuse, and you can see we do have power back to the control panel here. Like I said, we still need to run it and see if anything's causing the fuse to blow. So we're going to put a small bowl or cup of water inside of here before we run it to see if it's heating up the water and everything. So what we'll do here is just put it on a 1-minute cycle. See if it's running. Okay, and it started up and tripped the fuse again. It seems like it started up briefly, and then just went dead again. Alright, so you know, with the test we ran, we seen that we put the new fuse in, and the microwave did start up briefly, maybe a half a second, and tripped that fuse, or appeared to trip the fuse again. So we double checked the fuse, and it did in fact blow the fuse again. So that does mean that we have something causing that fuse to trip when we go to start up the microwave. So usually that's a sign that the capacitor is bad, just from seeing it happen before and knowing. But what we'll do then is we're going to test our capacitor now, and of course you want to discharge the capacitor again after we had a power applied to it and ran the test. Make sure you discharge the capacitor again. And what we're going to do to test it is, I have a digital meter here, and it's a little different from a digital to an analog meter. But on this one, what we're going to do is put it on your voltage setting, on the DC voltage setting. And when we hook our meter leads onto the capacitor here, we should see a spike or a jump in the on the reading on our meter here. It should go up and come back down, and then when you reverse it, after it comes back down and you reverse it, you should see a spike and a drop. And I did get a spike and a drop both ways that I did it. So that would mean that our capacitor is good. Okay, so now that we tested the capacitor and the capacitor tested good, we'll move on to the transformer and test the transformer. Basically, we know there's an issue on the high limit, or on the high voltage side of the microwave, that's blowing our fuse for us. So there's 3 components to the high voltage side. You have your transformer, capacitor, magnetron. So with already testing the capacitor, we'll move on to the transformer. We're going to remove the terminals from the transformer so we can be able to test it. Alright, so you have a primary winding and secondary filament winding on your transformer. This is going to be a resistance reading on your ohm scale of your meter. So we're going to go between our low voltage primary winding here. Between the 2 terminals, we should get about 1 ohm, and that's what I'm reading. It's about 0.9. And from either one of these terminals to ground, you can just go to the cabinet or a ground screw, ground terminal you find on the microwave. Either one to ground should be 0 ohms, and that's what we're reading. So now we're going to go up to our filament winding, or our secondary high voltage side of the transformer. You're going to go, if you go from there to ground, we should have 0 ohms, and I'm getting about 118 ohms. So this is where our problem lies. We have a bad secondary winding, or high voltage winding, on our transformer. So the transformer will need to be replaced on this microwave. Thank you for watching another quality video from ApplianceVideo.com.